Now we are going to see the type 2 problem. Obtain the state model for the given network in the standard form. The standard form is nothing but the physical variable form. When compared to the previous problem, here we are having two loops. 1, 2. We are having two loops here. As we already know, E of t is taken as the input. In state space representation, it is U of t. And E naught of t is taken as the output. In state space representation, it is Y of t. Also, we already know the currents and voltage of the energy storage elements are taken as state variables. Here we are having two inductors. For current flowing through inductor 1, that is I1, is taken as one of the state variable, that is x1. Current flowing through inductor 2, that is taken as x2. And voltage across the capacitor is taken as the other state variable, that is x3. Now we must find the state equation and the output equation. The state equation and the output equation together constitute the state model. Somehow I need to find the state equation and the output equation. So I must find x1 dot, x2 dot and x3 dot. To find x1 dot, x2 dot and x3 dot, first of all I am taking loop 1. I am taking this loop alone. and I am writing KVL. Therefore, input voltage is equal to sum of the voltage drops, that is L1 into dI1 divided by dt plus voltage across the capacitor, that is Vc. Then I am rearranging the equation such that I must get x1 dot. Therefore, I will keep this alone in the left hand side and I will transfer all the other parameters to the other side. Now, after rearranging, I am getting this expression. From this, I can say this is dI1 divided by dt is x1 dot, and this E1 is transferred to U of t and Vc is transferred to x3, as we already mentioned here. Now take this as equation number 1. To find x2 dot, I am considering the second loop, this loop, and applying KVL. Therefore, voltage across the capacitor is equal to the voltage drop across the inductor and the resistor. For Vc is equal to L2 into dI2 divided by dt plus current into resistance. From this, again I am having a differentiation term here. This can be kept in left hand side and all the other parameters can be transferred to the other side. So I am obtaining this expression. From this, I can write x2 dot and Vc can be written as x3 and I2 is written as x2. This total equation is considered as equation number 2. To find x3 dot, I am considering the current flowing through the capacitor. Current flowing through the capacitor is given by C into dV by dt, that is nothing but the difference of the two currents. If you see the currents, both currents are in clockwise direction. Current through the capacitor, both the currents will be in the opposite direction, therefore minus. From this, I can find dVc divided by dt. Therefore, dVc divided by dt can be transferred as x3 dot, and I am obtaining the third expression. With these three equations, I can easily frame the state equation. With the help of these three equations, I am framing the state equation in the matrix notation. This whole part is A matrix and this part is nothing but the B matrix. Now I found out the state equation. Now I want the output equation. This is my output equation. Now I want y of t. To find y of t, I am taking the output. That is nothing but E0. E0 is nothing but the voltage across the resistance. This resistance, voltage across the resistance. Therefore, considering the voltage across the resistance, that is nothing but I into R. I into R, that is I2. Therefore, y of t is equal to, this can be transferred as x2. This E0 is transferred as y of t. From this equation, I am forming the matrix. Here there is only x2, therefore x1 and x3 are 0. Mostly this D matrix would be 0 since this is known as the feed forward matrix. The feed forward matrix, any data which is transferred from the input directly to the output. There is no such data transferred from input directly to the output. Therefore, this D matrix will be equal to 0.